Welcome to the trials and tribulations of my 8-bit breadboard computer build. I was able to complete the A and B register of Kit 2, however with the instruction register I had some issues. In this clip, we have the A register and the B register. As mentioned before, I'm having issues with the instruction register, but we'll put that on hold for now. I went forward and started building the ALU. I've also loaded some numbers into the registers to help test the ALU. Register A has 7 loaded into it, and register B has 3 loaded into it. So we want to get the correct calculation in testing the ALU. As a reminder, our arithmetic and logic unit will be either adding or subtracting. So we either want 7 plus 3, which is 10, or 7 minus 3, which is 4. And in binary or in the LAD output, it should look like 0, 0, 0, 0, 1, 0, 1, 0 for 10, or 0, 0, 0, 0, 1, 0, 0 for 4. And I will go ahead and finish building the ALU and we will test it out in the next clip. Okay, so here is what I have for the ALU. As you can see, we've got something pretty funky going on. I'm not too sure on what the problem is, but we will troubleshoot it as always to see what exactly the issue might be. So far, it's completed as it should be, following the YouTube videos on Ben Eater's channel. But I clearly messed up somewhere. Here is just a photo of my build for Kit 2 out of 4 of the entire project. At this point, I've built the A and B register without a hitch. In Kit 2, the instruction register and the ALU are having complications, and for some reason they're syncing with the clock pulse. So I'm redoing my registers, the instruction register, the A register, and the B register because of the complications with the ALU and the bits syncing with the clock pulse versus displaying either a 0 or a 1. Plus, in the actual kit, you have about 40 220 ohm resistors. Here you can see it in the pamphlet listing of the items that come. However, in the YouTube videos that you're supposed to follow, they aren't included. In the photos in the pamphlet, they aren't there either. So it is a bit puzzling. I figured I would reconstruct the registers with the 220 ohm resistors on each LED, plus going over the schematic in the pamphlet because the resistors are mentioned there. So I am trying to truly take my time with this reconstruction and making sure that everything is connected correctly. Once I have finished, we will go ahead and test it out. I wasn't hoping it would be this much of a task to troubleshoot the issue, but this is the only way I feel like I can troubleshoot my issues. Adding these 220 ohm resistors does mean a little bit of redesigning the setup so that we can still have that clean display of the LEDs. Here is just a bit of a little close-up of how I've set things up before I hook up the wires. Oh, hi, baby. Looks like I have a spy over there wondering what I'm doing. But again, with this close-up here on the breadboard of my A register, I'm just zooming in, kind of showing you how I've done my design with the new resistors there and the LEDs, and making sure the positive outputs are still connected to the chips while my negative ends are linked with my resistors. So I'm building the B register simultaneously, and then I'll go ahead and build the instruction register with the resistors, and I've had my biggest issue here since it was also syncing with the clock pulse, as you've seen in the last clip. Here are the issues I've encountered with Kit 2. So both of the instruction register and the ALU have bits that are syncing with the clock pulse, and now adding the 220 ohm resistors that are not in the YouTube videos or the photos, but they appear in the schematic. I have reconstructed the A register with a 220 ohm resistor for each of the LEDs. Now, adding the resistors to the LEDs does mean that you have to implement a bit of a new design because the LEDs are no longer hooked directly to the low charge. We now have to make room for the resistors to be the middleman. So that requires giving up some space on the breadboard. As we've mentioned, this is not shown in the YouTube videos or in any of the photos to help figure this out. You can see for yourself on the pamphlet. However, if you do take a look at the schematic here, let me flip it a bit. This way, you can definitely match it up with the build, and it's the only place that you'll find those resistors mentioned. So the schematic can help you map out what to do. However, pay careful attention to some of the pins on the schematic, or the labeling rather, that don't match up. For example, on the schematic, you have Q3, Q2, Q1, Q0, but it doesn't start off the same or in the same order compared to the circuit reference here. The chip I'm talking about is the 74LS 173. It starts at Q1 instead of Q0. It actually goes down in this direction, top to bottom, instead of the bottom to top like it shows in the schematic. So just be vigilant there on the labeling. You'll also be able to see where the clock is hooked up, where the ground is, where your enable are, so very useful information. The circuit reference and the schematic alongside your build will help you better understand how to put it together. The YouTube videos are more like a tutorial, and the schematic and the circuit reference are really what helps. So the register I worked on before, here it is. Only one of the LEDs was lighting up, but then I jiggled it a bit. I had already swapped out any of the LEDs that were burnt out. I just think it's a bit sensitive, so I'll continue to work on that to see what's exactly going on. However, we'll just move forward and test this register out with the ohm resistors. So let's go ahead and set enable to low. Okay, great. It's lighting up as it should be, loading ones into our bits. Now we are going to go ahead and load it onto the bus. Well, hold on. Before I load it onto the bus, let me switch the wire from enabling data from that clock pulse to saving it onto the register. So we're and then by setting it back to high, now we can go ahead and load it onto the bus, which is working nicely. Now I'm going to stop enabling onto the bus, and we're going to clear the register. So set that green wire to high, then low. So now our register is back to all zeros. But we can load it back to all ones, and we can test setting the output using the bus by setting some of those LEDs on the bus to ground or to the negative side of the bus there, or if you want low. So we can just do this. We can do 2 for a quick demonstration. So now when we load it, we should see that 2 of the corresponding LEDs as zeros or simply turned off. But now I want this reflection on my register too. So let's take a look here. Okay. So that's great. Now, since we're loading from the bus now and not the clock pulse, now that they are connected, we have the same outputs on the bus and the register. Very good. So I'm happy this is working. I was done with part of the kit already, and since I was troubleshooting the instruction register in the ALU, I noticed all those resistors, but I haven't seen them being used in the tutorial videos once or in the photos, so maybe that's the key to my problem. Doesn't hurt to try, right? Now I'm going to work on the instruction unit, making sure things are connected well with the new setup with the ohm resistors. I do know that the chips have resistors in them, however, it's in the schematic. So we'll keep this new setup going. We'll do it for the ALU after the instruction register. Here are the issues that I've been having again. And thank you so much for watching. I do appreciate it. And until next time.